For test automation in CarMaker, in addition to Test Manager and Script Control, we also provide the Python API that enables to write and execute CarMaker test runs. The API can be used as a substitute for our Test Manager to control the simulation or to run multiple simulations in parallel within a runtime automation setup. The Python script and the simulation program are run concurrently, utilizing asynchronous execution to achieve this. Before running your scripts, ensure that your Python environment is set up as described in our Python API Users Guide. To run a simulation, we provide two classes: Runtime and SimControl. Runtime is used for running simulations without interacting with them during execution. It also offers to queue up multiple simulations and the option to execute them in parallel. SimControl allows interaction with the simulation via APO connection while it is running. In this example, we first select the project we are working in, load an example test run, then there is the vehicle load defined, and it is stored to myInfo file. Due to it is the test run parameterization, you can find the stored file in your project folder under Data Test Run. The changed values can be found here. Let's have a look at the second example. This time we want to directly run the simulation with the parameterization, which we are creating. I will use the test run break-mu-split because this test run has already a named value defined where I want to create a variation from. In this case, the named value is speed. More about named values, please have a look at our online tutorial Test Automation or our Users Guide. Variations have everything necessary to run a simulation. Here you can set a named value or a key value before giving it to runtime to actually run the simulation. Sometimes it is necessary to connect to an already running CarMaker executable instead of starting a new one. This is possible with SimControl. In this example, a new CarMaker executable is created, and then we use an APO server to connect to the new application. Note that we are using connect instead of start and connect now. You can also use a custom created CarMaker executable by setting the execution path. The Python API is not using the output quantities defined in the GUI. Instead, you have to define the quantities by yourself in the Python script. First, you have to create a variable with the output quantity type and then add the quantities you want to save. You can also change the output format from the default ERG files to another format like this. In this case, we use MDF. At the end, you have to add this to your variation, like this. After we have defined which quantities should be stored, we also have to decide if we want to save the whole simulation from start to end or just a part of it. We can save the whole simulation by setting the storage mode to save. Or if we are using SimControl for our simulation, we can save a specific part of the simulation. When we use the storage buffer, we can call save storage buffer. At a specific time of the simulation, we can save, for example, 3 seconds before and 3 seconds after the call was made. Or we can use start storage save all to save everything from now on. To finalize the saving and actually create the ERG file, call the function simcontrol stop storage save all. Now let's have a look at some example. Here I extended our one-time minimum example script to save the simulation results. I set the storage mode of the variation to save. This way the simulation is stored for the full duration. Then I set the output format to MDF. This way it will use the industrial standard MDF instead of our ERG format. With variation get results file path, we can get a list of all result files. In this case, it is the path to the MF4 file. Here you can see the path, and we can see here a new folder is created. And here is the result. In the next example, the storage mode is buffer. And we are calling save storage buffer when a specific condition in the simulation is reached. In this case, when the simulation time is greater than 5. Then the previous 2 seconds and the following 3 seconds are stored. Please realize that the saved time span is not exactly from 3 to 8 seconds. This is caused by a small delay in the APO communication. To create the file at the end, we have to call stop storage save all after the simulation is finished. Let's have a look at the result in IPG Control. Instead of using save storage buffer to save a specific time span, we can also save everything after we call start storage save all. In this case, we are waiting for 3 seconds and then save the result. Please realize that if we are using the sleep function of the CM API, it will only be 3 simulation seconds if you will let the simulation run in real time. Thank you for your attention.